Failover and redundancy. When two identical Cisco ASA are set up in failover, one of the appliances, the active appliance, is responsible for creating the state and translation tables, transferring the data packets, and monitoring the other unit. The other security appliance, the standby appliance, is responsible for monitoring the state of the active unit. The active and the standby appliances are connected through a dedicated network link to send failover-related messages to each other. This connection, known as a failover control link, is established over a dedicated failover LAN interface. When a failure occurs on the active appliance, the standby takes over the active role and starts forwarding traffic. This newly active appliance also takes over the IP and MAC addresses that were used by the previous appliance. After the failed unit recovers, it assumes the standby role. The failover control link provides a medium over which the two security appliances can communicate and update one another about the unit state, network link status, hello or keep alive messages, MAC address exchange, configuration replication from active to standby. Figure shows the Cisco ASA devices connected to each other through the Gigabit Ethernet. The Gigabit Ethernet 0/2 interface is used as the failover link shown as the dotted line. Failover interface test. To ensure that a failure properly dedicated on the monitored interfaces before initiating a failover, the security appliance goes through 4 different interface tests. Number 1. Link up or down test. The security appliance determines the status of its network interface card NIC by doing the link up or down test, which finds out whether one of the ports on the security appliance is not plugged into an operational network. In this case, the security appliance marks the interface as failed and initiates the failover process. Some examples of this failover include hardware port failure, unplugged cable of an interface, and failure on the hub or switch to which the interfaces are connected. If the interface passes the link up or down test, the security appliance moves to the network activity test. Number 2. Network activity test. In this test, the security appliance counts all received packets for up to 5 seconds. If the security appliance receives any packet during this time interval, it stops this test and marks the interface operational. If no traffic is received, the test is inconclusive, so the security appliance proceeds to the next test. Number 3. ARP test. In the ARP test, the security appliance reads its ARP table for the last 10 acquired entries. It sends an ARP request to those machines one at a time, and then counts packets for up to 5 seconds. If it receives traffic during this time window, it marks the interface as operational. If it does not receive a response from the host, it moves to the next host and sends an ARP request, and so on. At the end of the list, if the security appliance does not receive any traffic, it moves on the ping test. Number 4. Broadcast ping test. In this test, the security appliance sends out a broadcast ping request and then counts all received packets for up to 5 seconds. If it receives any packets during this time window, the security appliance declares this interface operational and stops the test. If the appliance does not receive any traffic, it marks the interface and failed and initiates failover. A stateful failover. When a connection is established through the active appliance, Cisco ASA updates its connections table. A connection entry includes the source and destination IP addresses, protocol used, current state of the connection, the interface to which it is tied, and the number of bytes transferred. Depending on the failover configuration, the security appliance takes one of the following actions. A stateless failover. The security appliance maintains the connection table but does not replicate entries to the standby appliance. A stateful failover. The security appliance maintains the connection table and replicates it to the standby appliance. In a stateless failover, the active appliance is not responsible for sending the state table updates to the standby appliance. When the standby unit becomes active, whether by detecting a failure or by manually switching over, it has to build all the connection entries from scratch. This causes all the stateful traffic, such as TCP, to get disrupted. In a stateful failover, the active appliance sends an update to the standby unit whenever there is a change in the state table. In this mode, the active appliance sends stateful updates over a dedicated link to the standby unit. When the standby unit becomes active, it does not need to build any connection entries because all the entries already exist in database. This dedicated connection is known as the stateful link. Hardware and software requirements for failover to work properly. The following specification must be identical. Product or model number of the appliance. For example, both appliances must be Cisco ASA 5520. You cannot use an ASA 5520 and ASA 5540 in failover. Amount of RAM. You cannot use 1 gig of RAM in one appliance and 2 gig in the other one. Number of interface. Both appliances must have the same number of physical interface. External module. If you have security modules such as SSM-IPS, then both appliances must have it. Activation key with the same features. Activation key must have the same features such as the failover model, encryption level, and the number of VPN pairs.